Yes, you are welcome to the classes for today, and we are in chemistry. We are talking about types of reaction. Types of reaction. Now, there are different type of reaction, and I think at the same time I will be telling you which of these is not the major type of reaction. But first of all, the types of reaction we have is combination reaction. We have decomposition, displacement, double decomposition, catalytic reaction, reversible reaction, thermal dissociation, and redox reaction. Now, there is one which is not a really type of a reaction, which is under the subgroup of is neutralization reaction. So neutralization reaction precisely is not really one of the type of reaction, but in the course of our explanation you understand. Now let's take the first one, combination reaction. Combination reaction. Now in combination reaction, because you must know how to identify this type of reaction, in combination reaction you have only one. Now we have the reactants given to the products. Now, reactants given to the product. Now, in a chemical change where you have the substances that are reacting, because in a reaction takes place for chemical change, not a physical change. And that is one of the differences between the physical and the chemical change. For the chemical change, there is a reactant and there is a product. And this reactant, they react based on electron changes. Giving of electron, taking of electron in bonding, giving it to the compound, and there is a chemical change. Like talking about the difference between compound and a mixture. There is a chemical change in a compound, you have a chemical reaction. And those reactions, when the reactants, when they react, they give you the product. Now, for a combination reaction, in combination reaction, there is only one product, like A plus B given to C. In combination reaction, there is one product. So it is only a product you see. So any reaction where there is only one product that is what we call combination reaction. And this combination reaction, most cases you see it like in an organic compound. But you still see it. Take for example, if hydrogen reacting with chlorine to give hydrogen chloride. It's like an example of a combination reaction. There are two or more reactants. Even like this, if you have calcium oxide reacting with carbon 4 oxide to give calcium trioxocarbonate, which is also a combination. There is always one product. Please take note of that in combination reaction. In decomposition reaction, it's like the reverser. In decomposition reaction, there is only one reactant. There is only a reactant. Take for example, if you have your ammonium chloride giving it to ACl plus NH3, something like that. So you see that there is only one reactant. So you have decomposition, and decomposition reaction can also be a thermal decomposition. Thermal decomposition is when heat is involved in that decomposition reaction. So you can call it thermal decomposition. Thermal decomposition reaction. So please take note of that. Then the next one we want to talk about is displacement. Now, in displacement reaction, you have to understand the electrochemical series, because the one that is stronger in the electrochemical series will displace the one that is less stronger. Excuse me. Like the one that is more electropositive will displaces the one that is, and the one that is more electronegative will also displaces. Take for example, I think this is like number 2 you're talking about. Then number 3, we are talking about displacement. Displacement, let me say AB reacting with C to give you AC plus B. Now what is happening here between A and C? So C is more electropositive. I'm just giving an example. I will give an example, and it will displaces A from this. It displaces A, and sorry, what it will give you is CB plus A. Sorry for that. You see, this C with A, it displaces A to form the CB, and A is displaced out. So that is displacement reaction. So in displacement reaction, you have to know the electrochemical series, and you know the electrochemical series, like for the electropositive, like potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, mercury, silver, gold. It goes like that. So for example, if you have a solution, for example, if you have like magnesium chloride to react with sodium. So you see what's happening now? Magnesium chloride react with sodium. Now look at magnesium, look at sodium. Look at the electrochemical series. Sodium is more electropositive than magnesium. So it's going to displace magnesium away to have your sodium chloride, and magnesium will be isolated. So this is an example of a displacement reaction. In displacement reaction, you have to know the electrochemical series. For example, again, potassium iodide plus chlorine. Take for example potassium iodide. If you look at this is the electropositive. On the electronegative, fluorine, bromine, iodine, it goes like that. So you see that chlorine is more electronegative than iodine. So when you look at chlorine and the iodide, this is the anions. So you see them, it will now come here. This is chlorine negative, this is negative. It will now displaces iodine, and you now become potassium chloride plus iodine. So you see what's happening. This is potassium iodide plus chlorine. Now this is where at this point electropositive, they are displacing. At this place electronegative. So it looks at the iodide and it displaces it to form potassium chloride, because chlorine is stronger, it's more electronegative than iodine. So you see, this is displacement reaction. Then the fourth one we want to talk about is the double decomposition. Now in double decomposition, it is the exchange of radicals. Look at it. AB reacting with CD to give you what? AD plus CB. This is the positive, negative, positive, negative. It's the exchange of radicals. So your A goes with D and your C goes with B. So it's the exchange of radicals. Most cases, by the time we are going to talk about by the time we talk about volumetric analysis, we're talking about acid, base, and salt, and neutralization reaction. We'll be talking about production of salt, the insoluble salts, and also production of volatile substances. Most of the volatile substances are insoluble that will be precipitated from the solution is always double decomposition. So, but please don't make a mistake with double decomposition to decomposition reaction. People want to look at really the double decomposition is supposed to be called something like double displacement in terms of the operation, but this is just the name it chooses to be. So please, double decomposition is the exchange of radicals. So you can see that when in short, like a good example, like, and that's what I want to explain in neutralization reaction. Like for example, when you see your ACl reacting with sodium hydroxide, normally it will be sodium chloride plus hydrogen OH, and this hydrolyzes to form water. So now this is where I'm going. You see, neutralization reaction is not really, there was a question like that, and they say which of these below is not a type of reaction, and they made mention and they put neutralization. Neutralization reaction is not really a type of reaction. It falls under double decomposition, exchange of radicals. You see what is happening here now. So that is neutral double decomposition. Then the fifth one we want to talk about is catalytic reaction. Now, for catalytic reaction, number 5. For catalytic reaction, it's really involving of catalyst. Any reaction in which catalyst is involved is a catalytic reaction. So more or less, you can have a catalytic combination reaction, you can have a catalytic decomposition reaction, a catalytic displacement, a catalytic reversible, catalytic redox, and the rest. So we have all this, but that is just a catalyst is involved. So that's why sometimes you have to understand all this type of reaction. They can write a reaction whereby so many type of reaction is involved in that, and I'm going to give you an example. But first of all, know a catalytic reaction. Catalytic reaction is a reaction in which catalyst is involved. Now let's see some little things about a catalyst. Now, what is a catalyst? Now, really, a catalyst is any substance that alters the rate of a chemical reaction. Any substance that alters the rate of a chemical reaction. Now, most people make the mistake, you say a substance that increases the rate of chemical reaction. No, a catalyst can decrease the rate of chemical reaction, or it can increase the rate of chemical reaction. But the thing we know is that it alters the rate of a chemical reaction. And reaction could be we should have now when you come to reactions under catalyst, you can have an homogeneous catalyzed reaction, and you can have the heterogeneous catalyzed reaction. Now I'm talking about in terms of catalyst, it can be grouped, all reactions under catalyst can be grouped under an homogeneous catalyzed reaction or heterogeneous. Now when we say homogeneous, that this type of reaction is homogeneous catalyzed, that shows that the states of the reactant and the product with the states, physical states of the catalyst, they are in the same phase. Phase in the sense that they are gaseous. Take for example, if hydrogen reacts with iodine to give you hydrogen iodide, this is in gas, this is in gas, this is in gas, and sometimes you can use nitrogen 2 oxide in this catalytic reaction, which is also a gas. So you see that this one is a gas, this one is a gas, this one is a gas, this one is a gas. The catalyst you are using, nitrogen 2 oxide, is also a gas. So you can call this is what they call homogeneous catalyzed reaction. Everything, both the reactions, the product, the reactants, and the catalyst is in gaseous form. Now, but if you have another state in which, like in the production of ammonia, that would be a good example. In the production of ammonia, like with H2 to give you NH3, and you use your ion filings. Now this is gas, and this is gas. When nitrogen reacts with hydrogen to give ammonia, and you are using ion filings as your catalyst, which is in solid form, this is a heterogeneous reaction. So you see that the reactions, in terms of reactions used by catalysts, it can be two types. That's what I'm saying: homogeneous catalyzed reaction and heterogeneous catalyzed reaction. Now, on catalyst, we have defined it, and I've told you the type of reactions based on the catalyst. Now, catalyst is also in two forms. Generally, we have the organic catalyst and we have the inorganic catalyst. Now, the most cases, it is now the organic catalyst. For those of you in biology, those are just the enzymes. They are the organic catalysts that you can see there, like the xylene in the mouth, in the salivary gland, like the pepsin and the renin in the stomach, like the one in the pancreas, which is the lipase, the amylopsin, and the trypsin. You just have them like that. Those are organic catalysts present in living. While we have the inorganic catalyst, and that is like most of the one we are going to be making most mention of mostly the inorganic catalyst, which you find in your organic compound. Now, catalyst, just to talk a little about catalyst. Catalyst Now, catalysts have some properties. What are some of the properties of a catalyst? Number one is that the catalysts are specific. When we say catalysts are specific, that is, they act on a substrate. They act on a type of reaction. Now, although in the inorganic catalyst, sometimes some of them they can act in two types of substrates, and there are two types of substance, two types of reaction. Ion failing can act in different, but when you come to like the organic, most of them they are very, very specific. But for the inorganic, they are also specific, but not all that specific. Come to catalyst. Then number two, catalyst does not affect the equilibrium in a chemical reaction. It does not affect the equilibrium in a chemical reaction. Now, what I'm saying that it does not affect the equilibrium in a chemical, by the time we are going to talk about Le Chatelier's principle in the production of some gases like ammonia and the rest, we are going to explain more about it. But the equilibrium in which especially during the reversible reaction, where the forward and backward reaction is being taken, catalyst does not affect the equilibrium, the state of the equilibrium. Catalyst only works, it does not initiate a reaction. So catalyst is not the one that will bring up the reaction. It will not the one that will start the reaction. It is a reaction that is on process, on progress. That is what the catalyst works on. So it does not initiate. Then number four, catalyst does not affect the products. When we use a catalyst, we now get another product. No, it does not affect the product of the reaction. So you should take note of that. It does not affect the product of the reaction. And catalyst is always needed in small quantity. It's always needed in small quantity. Really, the amount of catalyst, to some extent, the amount of catalyst increases. The rate of, as the amount of catalyst increases, the quantity increases, the rate of chemical reaction increases, but up to a level. A maximum state is gotten to in such a way that even any other amount of catalyst will not affect the rate of chemical reaction. So as you increase the amount of the catalyst, it also increases the rate of the chemical reaction to an extent. Then another point is this: a solid catalyst, like I was telling you about nitrogen reacting with hydrogen to give ammonia, that we are using ion filings, which is solid. Now, if you increase the surface area of the catalyst, that is, let's say the ion filings is grounded in powdered form and used, it also increases the rate of chemical reaction. So the state of the catalyst affects the rate, just like the state of the reactants too. And take for example, if calcium hydroxide is reacting with carbon dioxide, we give, now this is solid, this is gaseous, this is solid. Now if this one is also grounded in powdery form, the rate of chemical reaction will increase. But what I'm trying to say is that the catalyst that is being used, if you increase it to the surface area by grinding it, it also increases the rate of chemical reaction. So that's about catalyst. Now, which is specifically the inorganic catalyst. But when we come to the organic catalyst, we'll be talking more again that the organic catalyst is proteinous. The organic catalyst is specific. It works on a substrate. The organic catalyst, which is enzyme, works on an either acidic or alkaline medium. The pH of the reactants is very important. All those ones goes. But we are talking about the inorganic precisely now because we are on this part. Now, in the catalytic reaction, a catalyst could also be a positive catalyst or a negative catalyst. So that is another thing. We have a positive catalyst and we have a negative catalyst. Now, a positive catalyst is the one that increases the rate of chemical reaction. So please don't make the mistake of saying a catalyst is something that increases. No, a positive catalyst increases the rate of chemical reaction, and a negative catalyst decreases the rate of chemical reaction. And most of like the ammonia I told you about and the rest, the ion filings increases the rate of chemical reaction. Now, take for example like hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide is, I think it is, okay. Hydrogen peroxide, we have the tetrahydrophosphate and 5-acid that decreases. So this is a negative catalyst. It decreases the decomposition of hydrogen peroxide to water and oxygen. You see the hydrogen peroxide, you see antiseptics that is sold in the pharmaceutical center and co. Is in a liquid. And one other thing that increases the decomposition is light. Light, if you look at the bottle that they use a reddish, darkish bottle in taking hydrogen peroxide because they don't want light to penetrate to decompose the hydrogen peroxide. And they added some quantity of tetrahydrophosphate 5 into the solution because it's a negative catalyst preventing the decomposition of hydrogen peroxide. So use an example of positive and negative catalyst. Then we have promoters and inhibitors. Promoters and inhibitors. What are promoters and inhibitors? Promoters, they don't act on the substrate, they don't act on the reactant, they act on the catalyst. So a promoter increases the activity of a catalyst, while an inhibitor decreases the activity of a catalyst. So please, you should understand a question like this. If they say they use a promoter on a negative catalyst, what will happen? A promoter on a negative catalyst. A negative catalyst decreases the rate of reaction. So when you promote the activity of a negative catalyst, it will help to really decrease the activity of that reaction. If they say they use an inhibitor on a positive catalyst increases, then they put an inhibitor to inhibit it, then what will happen is going to what? Decrease, because the positive catalyst increases, but you use an inhibitor to do it, so it will decrease, so the reaction will generally be decreased. So you must know when they use a promoter for positive and negative, and when they use an inhibitor for positive and negative, to understand. But promoters activate the activity of a catalyst, while inhibitor inhibits and prevents, diminish the activity of a catalyst. So please, these are the things you want to know of a catalyst. Then the next one is reversible reaction. Now, a reversible reaction is a reaction that has the forward and backward reaction. For example, when you have A plus B, it's reversible. Or let me put it plus D. So it's reversible. It can go forward and it can go backward. Now, I want you to understand something about reversible reactions. That most reactions, they are really reversible to some extent, but depending on the state of it. If it is in a closed system, reversible reaction. But if it's not in a closed system, you just see one of the substance is being either evaporated or lost into the environment. And when one of them also ionizes, take for example, like sodium chloride, hydrogen chloride reacting with sodium hydroxide reacting with hydrochloric acid, acid and base are reacting and produces sodium chloride, salt plus water. Now look at this water. The water has already ionizes. So in this place, it's difficult for it to dissociate, to bring back. So most of them, when a product is being formed that ionizes, it cannot. But in most cases, a reversible reaction, all reaction can be reversed except when it is an open state, not in a closed system. If it's a closed system, you can see the level of reversible reaction. So that reversible and reversible reaction, we are going to do a lot about reversible reaction later. The state of reversibility, the energy changes, entropy, enthalpy, and all those stuff, activation energy, but we're going to talk more about that. Then thermal dissociation. Now I want you to look. Thermal dissociation is like the same thing. It's just the same thing with thermal decomposition. Thermal dissociation is the same thing with thermal decomposition, except that in thermal dissociation, it is reversible. So when you have something like ammonium chloride, ammonium chloride dissociates, heat is involved. So this is thermal dissociation. Thermal dissociation is a reaction whereby heat is involved, one, and secondly, it is reversible. We call it thermal dissociation. Then the last we are going to talk about is a redox reaction. Redox reaction. Now, in redox reaction, it's really a little elaborate, and we need to a lot of things. So I will take it in the next class. In the types of reaction, I will take the redox to explain redox, because redox reaction now, because that is like the new type of reaction that comprises of everything and able to know what is happening at different states, because the redox reaction is telling us that this is a reduction and it's oxidation. So it's like two things. It's explaining in terms of oxygen, it's explaining it in terms of electropositive, explaining it in terms of hydrogen, explaining it in terms of electronegative, explaining in terms of oxidation number increases, and also explaining in terms of electron transfer. So these are the six definition under redox reaction to explain everything. So in the next class for type of reaction, I will be taking redox reaction. So this type of reaction is the first class. The redox reaction will be the second class in the type of reaction. Thank you.